Back to the Pearson Edexcel Level 2 Certificate Sample Assessment Tutorial. This is paper number 2 of 2. We saw paper number 1 a couple of days ago. It was quite a fun paper to do. This is the calculator version, so bear that in mind. This should not take us very much time to factorize at all. This one's kind of cool, right, though, writing it in this form. Very, very unusual, cool question, I thought. These four things are, of course, multiplying together. That's what happens when you expand brackets. But what do we know about multiplying? Well, everyone should be able to do this really easily, because none of you are dumb enough to try and do 5 times 21 and then double it. You just do 5 times 2 is 10, and then times it by 21. You can change the order that you multiply things in, so we can just swap these middle two out. And then, of course, these two multiply out opposite of this, or actually, the opposite of this, right? To make x squared minus 9, and then these two can multiply together to make whatever quadratic it gives you there. Just a fun little question to get given there. Consecutive numbers, w, x, y, and z, we can write as, let's just say a plus 1, a plus 2, a plus 3. Now, the sum of those four numbers is clearly just 4a plus 1, 2, 3, 4, 5, 6. And what happens when you multiply the third biggest, or I guess the third smallest, I guess that is, times by the biggest, and then take away the two smaller ones multiplied together? Well, you end up with something that looks like this, and then if you expand those out, just like we saw before, and you cancel the a squared, take away an a there, you end up with the same thing. And I think that's pretty much done. I think that's all I really had to say. ABC and PQR are similar. Now, if one of the angles is 40 and one of them is obtuse and they're isosceles, isosceles means that two of the angles are the same, but we can't have two obtuse angles in a triangle because obtuse angles are bigger than 90. So that would make the total sum over 180. So there must be a 40 repeated twice, and if 40 is repeated twice, the remaining angle is 100. So we can draw this, right? And two of the sides of 10 means 10 is this side here. Can't be the longest one because, of course, that doesn't get repeated twice. So that's triangle ABC. It doesn't matter how you label this ABC, so I didn't bother, because the next triangle, PQR, is just that triangle times by 1.5, which will just make it a 15 there. Again, this length here is kind of irrelevant. You could do some maths to work out what it is, but it's irrelevant. It would still be times by 1.5 to get to here. And then, of course, if this is 15, it's still isosceles. This is also 15. The angles are no different. Of course, we can just do half AB sine C, and we'll work out the area of that triangle to three significant figures, which is what it asked us to do. So these is xy coordinates up here, xy, xy. So okay, well, we just put x is 0 and y is 0.7 into there. B to the power 0 minus 0 is just 0, right? That's just 1, so a is 0.7, which you can then use when you also put this x and this y into there. You can also put the a in that you just figured out. Divide both sides by 0.7, and then you could do some stuff here, or you could just take the minus 3th root of both sides, since that's totally allowed, and just type that in the calculator and you get b is 2, and those will be our two answers. So we're sketching this now, but we know a is this and b is this. And so, of course, when x is 0, it goes through 0.7. That's just what that says. So we got x down at 0.7 maybe. And now when you've got a minus power here, that means the exponential is going the other way to usual, like this. And that sketch will do. We've got an asymptote here, but it didn't ask us to label that. This is going to be a terrible graph of sine of x that I did in PowerPoint. It's supposed to go through 0, 0. You get the idea. It's the one that goes like this, as opposed to cos, which starts up here and goes down. You should all label, though, bear in mind that this is at 1, and of course minus 1 below it should definitely be labelled. And that's the minus 1, it's just the minuses over the grid. Anyway, factorise this, super easy, and then of course either 2w plus 1 is 0 or w plus 1 is 0, and you solve both of those to get those two answers there. The reason they asked you to do that is because they're kind of leading you in towards this question at the end here. First, it wants you to do a very quick proof of the Pythagorean identity, sine squared plus cos squared equals 1. So the way that I chose to do this was just label the sides a, b, and c, which of course means that a squared plus b squared equals c squared, because we know this is a right angle triangle, it tells us. And then I said, well, okay, looking at this triangle here, if I first divide both sides of this equation by c squared, which will give me a 1, c squared over c squared is 1, and then look in this area here, I think maybe first I separated this out. A squared over c squared is a over c all squared, right? But of course, a over c is just sine of theta, right? Sine of theta is a over c, it's opposite over hypotenuse, and cos of theta is b over c. So we can replace those two results in here, and we'll get sine squared plus cos squared equals 1, which is what I've written here, that's the same thing. You could also, by definition, just claim AC is equal to 1, and then by definition, sine of theta is the length of this side, and cos of theta is the length of that one. I'm actually not sure whether you'd be allowed to just say that, but that is totally true. Anyway, given sine squared plus cos squared equals 1 for all true values, we just proved it, I guess, solve this thing here. So we replace this cos squared. If you rearrange that for 1 minus sine squared, we just used it. It's hinted at us again that we need to use it again anyway. Cos squared is 1 minus sine squared. Put it in for this. So cos squared is 1 minus sine squared. Expand out. And we end up with that exact same quadratic we saw earlier. Just every time it's a w, we see a sine squared instead. It's the same quadratic. So this is going to factorize in the same way, just with a sine x instead of a w. And then it's going to solve in the same way, just with a sine x instead of a w. And then we look at the graph that we drew a couple of minutes ago. And it's saying, okay, well, when is sine of x minus half? Now, you could type that into a calculator and you'll get minus 30 immediately. And that's verified, right? Minus 30 is about minus a half, I guess. But then you look at the graph and you think, well, actually, there's another place that's equals minus a half. It's all the way over here at 150, or minus 150, I should say. And then, of course, when it does equal minus 1, well, the calculator will just tell you that's a minus 90 as well. So those would be the three answers to that question. Factor theorem is apparently in this course. That's interesting. Factor theorem says this. If f of a is 0, then x minus a is a factor of f of x. So we define that thing there over there to be f of x. Define this to be f of x. And then just shove in f of 2, I guess. And if that equals 0, which it totally does, which is nice, then that means x minus 2 is a factor, and we're all done. Hence or otherwise given this thing here. So what we want to do is write all of this in terms of 2y. So this here is 2y all cubed, because 2 cubed is 8. And this here is 2y all squared, because 2 squared is 4. And likewise here, it doesn't need as much changing. But then we can replace these with x's, right? And when you do that, you realize that you've just got the thing that you were looking at before. But we know x minus 2 is a factor, so we can just take that out. And lots of you will have been taught algebraic division here. I don't ever do that because I think it's really boring. So what I'm going to do instead is I'm just going to say, well, what do you have to times minus 2 by to get to 24? Well, you have to times by minus 12, right? And what you have to times x by to get to x cubed, you have to times by x squared. We're just trying to build the thing that you would multiply by this to get to this. So how do we get the middle term? Well, just shove in a plus ax. And then say, okay, well, I need minus 1x squareds. Right now I've got minus 2x squareds plus ax squareds. And like I said, that needs to equal minus 1x squareds. So that means a must be, I believe, plus 1, right? Because minus 2 plus 1 gives you this minus 1x squared here. And then, of course, it means that the answer is this. You can expand that out. You can verify the 14x by doing minus 2x here, and then another minus 12x from those two at the ends, makes minus 14x, so this is all perfect. And that itself, of course, very simply factorizes to this. And you end up then finally, of course, replacing the x's with the two y's, because it's asking you to factorize an expression in y. And you end up with this here, and you're all done. Kind of a harsh question, I thought, this, using trapezium rule. As far as I can see, you don't get given trapezium rule in the formula book. I don't think there really is much of a formula book, it doesn't seem like. And you also don't get given a picture to work with. So quite harsh, but you have to draw the picture yourself. You know what this looks like. It goes through at 1 because 2 to the power 0 is 1. And we're estimating the area between 1 and 7, it says, with 4 widths. So halfway between 1 and 7 is 4. So that means the 4 widths will go 1 to 2.5 to 4 to 5.5 to 7. So those would be our 4 trapeziums that we'll be using. And then we need to get out the, well, firstly, I guess we need to work out the height of all of these places here. So this is 2 to the power 2. Sorry, this is 2 to the power 1 because the x coordinate is 1. So the y coordinate here is 2 to the power 1, which is 2. Then this y coordinate is 2 to the power 2.5. I couldn't be bothered to work out what that was. 2 to the power 4 is 16. Just working out the heights of these red lines and so on. And then, of course, the area of each of these sort of approximate trapeziums, we're going to pretend this shape here is a trapezium by just drawing a straight line across it and saying the area of that trapezium is given by a plus b over 2 times h, where a and b are the two parallel sides of the trapezium. So in this trapezium's case, it's 2 plus 2 to the power 2.5 times h, which is the distance between them, which is 1.5, of course, with a divide by 2. And the same thing for the next one, and for the next one, and for the one after that as well. And then just type all that into a calculator. 3 significant figures gets you that answer there. A-level just gives you a formula for that, which is a bit easier to do, I guess, but whatever. Okay, so we need to label this picture with all the things that it tells us here. So that's that, that's that. This 49 refers to this angle here, if I'm not mistaken. And then 32 refers to this, sorry, the 109 refers to this angle here, and the 32 up to this angle here, which I'm just going to draw like that. Final length of CD. Now, firstly, we can work out CF by doing a bit of cosine rule on the triangle CBF, because we have the angle here and 2 sides there. So we can say CF squared is equal to this. That's just cosine rule being applied. I just typed it in and square rooted it straight away. Can't be bothered to type any more working than that. Now we can use this ratio rule to say if we have 3 parts here and 2 parts there, well, that's 5 parts in total. So you could just divide by 3 and times by 5. to work out C to E straight away. I actually worked out F to E by just dividing by 3, then times by 2, and then I added the two results together because I'm dumb, but whatever. You get this answer regardless. So yeah, that's just using some ratio to work out this total length. And then you need to sort of turn your head to the side and realize that actually you've got a very useful triangle here, which has a complete sine rule set up in it, because you can say that CD over sine 109 is equal to CE, which you know, over sine 32, just using opposite angles. And that's just sine rule times by sine 109. You should have ands in your calculator whenever you're working with this. So just do sine 109 times ands over sine 32, and you end up with this, again, to 3 significant figures. And that would be your answer. This person is buying cupboards. This is actually a linear programming question, which I was quite surprised to see in this. But hey, why not, I guess. Why is the number of 900mm cupboards? This just means that you need to buy, you're only allowed to buy more than 0 and less than 10 of them, I guess. Is all you have to say there, I think. And then it says, show where these two inequalities come from. Well, 210 lots of x, the number of 600s you buy, plus 240 lots of y must be less than your budget. If you just divide by 10 and then divide by 3, you get the first one. And then on the second bit, basically it's saying if you line all the cupboards up side by side with no gaps between them, it must make a width of less than 12. So, okay, 12 meters is actually 12,000 millimeters. So 600 times the number of x's you have, plus 900 times the number of y's, must be less than or equal to 12,000. Divide by 100, then divide by 3. And you end up with that constraint there. So that's fine. It's now got a picture. We can clearly see that this is the constraint x greater than 2. This is the one about y. Now, which constraint is this diagonal line here? Well, we just need to rearrange both of these to find out. If we take away 7x and divide by 8, we end up with a 15 as our y-intercept, which means this is referring to this one. And then if we do the same with this, we don't. So now we need to draw this line, as that's the one that's missing. Just type that into a calculator and you work out it's about this, roughly. At that point might be completely out. I wasn't really trying. And then, of course, when y is 0, you can quickly work out x needs to be 20, because 2 times 20 is 40, and then these things would cancel. So it goes through at 20 down there, just draw a line connecting them, and the region is everywhere less than, or within the space that's enclosed by everything, so it's in here. You have to buy positive numbers in x and y, so it's also enclosed by the x-axis, which I probably should have made more clear thinking about it, but in any case, who cares? So decides to buy 7 of the x's. So just shove in x is 7. You could use the picture, but I honestly couldn't be bothered. Just shove in x equals 7 into both of these and work out that y needs to be less than this or less than equal to that. Of course, you've got to buy a whole number of these. So that just means the most you can buy, both agree, is just 8. And then, of course, the amount of money you spend is just going to be however much the x's cost times by 7 plus however much the y's cost times by 8. And you'll get your total cost just there. And finally, question 10. Let's just say that the probability of taking a red is R and the probability of taking a Y is Y. Sorry, a yellow is Y. A few things we know here. Imagine a probability tree in your head. The way to take exactly one red is either to take red then yellow, which is R times Y, or take yellow and then red, which is just Y times R. But of course, those two things are the same, so you can just add them together to get 2YR. We're replacing it in, so the probabilities aren't changing. You're putting the bag back in, the situation is the same before, which is what makes this problem doable. So we get this here, we divide by 2, but then also, because they're only red and yellow, these two probabilities must add up to 1. So we can just rearrange to get y is 1 minus r. We're looking for the probability of y, so rearranging this for y is better, so just replace r with 1 minus y. Expand out. You can use quadratic formula, I guess, here. That works. And you get these two answers. Which one is correct? Because they're both between 0 and 1. It says that there are more yellows than red. So if the probability of yellow was 0.15, from here that means the probability of red would be 0.85, which means there would be more reds. So that can't be the answer. So the correct answer is 0.85. Again, I thought that was a really interesting paper. Interesting that we had to know something about factor theorem and about linear programming. And the trig solving thing also seemed to be the new maths involved here that's not strictly GCSE. So yeah, kind of interesting. I'll see you next time.